Let's talk about hair. Wheel. So hair is a protein. You guys know that? So hair is a protein. Consists of a bunch of small protein chain called alpha keratin. Okay. So the hair right here, if you look at really look inside, it's just a bunch of alpha helix, alpha keratin intertwine or wrap around each other. All right. Maybe a little bit more visualize here. So this is a cross section of your hair, and we have a macrofibril, and inside of macrofibril we have microfibril, a lot of it. And inside the microfibril, that's just a bunch of alpha keratin intertwined, wrap around each other. Imagine making a rope. It's just a bunch of strand of little rope, I don't know what they call it, wrap around each other to make the one big rope. Okay, your hair just like that. All right. Now, hair is a protein chain basically, all right, and protein is made of amino acid. You're probably familiar with all amino acid, essential, non-essential, whatever. I don't care. What we're going to talk about today is just one amino acid called cysteine. Okay, why cysteine is special? Because it's the only amino acid that have thiol in it, SH right here, SH group. All right, and we mentioned earlier on the previous video that thiol are easily oxidized. Even the oxygen in the air, right, can oxidize it. So this from non-oxidized become oxidized form. So they add on to each other like that. Okay, and that adds strength to this alpha keratin chain. Hair and nail are made of the same material, alpha keratin. But you guys know nail is much stronger than the hair, right? And because nail have more more cysteine in the protein chain than hair does. Okay, that's why it's stronger. All right, talk about straight hair and curly hair. Some of you who have straight hair, how do you make it curly? Let's say if you recognize this process. Okay, so first of all, your straight hair, so your hair just, let's say, straight up like that, alpha keratin chain. Some of them have some position have the thiol that bond to each other like that. Right, this is straight hair. Now, if you want to curl your hair, this is what you do. You're gonna add a webbing lotion, which is look like this guy. Right, this is a reducing agent. Reduce all this, cut the sulfide bond. Now, your hair from straight hair gonna become flexible hair. Still straight, but more flexible. Okay, and then we're gonna curl process using curling iron. The whole purpose of curling iron is we just change the position of the disulfide bond. This guy is supposed to form bond. This guy is supposed to form bond. This guy is supposed to form bond. But no, we change the position, so they will meet some other sulfide, and we add some lotion into it to keep it safe. It's actually an oxidizing agent. So the sulfide who already have the mixed position from a disulfide bond with some other sulfide, not the one that they're supposed to form. That's when your hair get curly. Okay, and adding heat into the curling process, it just speed up the disulfide formation. All right. Now, some people have straight hair, some people have wavy hair, and others have curly hair. How does it work? What control it? Of course, genetics. Genetics control everything. But how does it work? Right? Let's take a look here. So this is let's say this is your hair, all right? So for our communication, anything that above the skin, let's call it hair shafts, right? These are hair shaft. Anything underneath the skin, we call hair follicle. Okay, so start with the hair shaft, right? Curly hair people, you have a lot of disulfide bond than the others. So your hair consists of have more percentage of cysteine than the people who have straight hair. So you have more disulfide bond. Okay. Now next, another factor. There are multiple factors. Look at the hair follicle. Okay. So we're going to look at a cross section of the hair down here, hair follicle. If the cross section is circle, you have straight hair, oval, kind of wavy hair, and if you have a curly hair, your cross section is kind of flat, half circle, something like that. If you can imagine this, I'll give you some analogies. So let's say if you have a rope, the cross section of rope is circle, right? The cross section of rope is circle. Drop the rope to the floor. The rope still straight. It might curl a little because of the gravity, but I mean, it's still straight. Ribbon, on the other hand, the cross section of ribbon is flat, right? Flat cross section. Drop ribbon on the floor, they start curling. Okay. Same thing with your hair. Your hair, the follicle, the cross section of your hair, the geometry, the structure of it, circle, that's straight, oval, wavy, and that's kind of a little bit more flat, that's curly hair. Okay, and another one. So follicle tunnel. So look down here, follicle tunnel. If the tunnel is straight up, your hair is tend to be straight. If your tunnel is kind of curved, that's when your hair get curly. This is totally genetics here. You're born with one. Okay. All right, that's it. Now let's go to the last functional group of this course: sulfides and thioester.